So as we look at test construction and statistics, a lot of this is going to be review for you. Hopefully you remember some of this stuff with bell curves and distributions and as we get the scores from somebody who has taken one of our measures. In this case, we'll use it to describe it from intelligence tests because those fall on a nice, neat, normal bell curve. So the first thing we'll talk about is what this bell curve means. Basically, this is your frequency distribution of scores. Now, as time has gone on, intelligence test scores have increased. The average intelligence test score has increased over time. For whatever reason, whether it be because of access to information, access to technology, access to education, better health, better focus on the importance of education, whatever it might be, those have increased. Even though the increase of score, the average is going up, what has often happened is the average score on a measure has stayed, or they've placed it at 100, and then the distribution of scores around it. Now, the average is probably closer to 104, 105 these days, but this bell curve being put here, the distribution is still even, which is it's still normal bell curve. It's not skewed, which indicates higher reliability and validity. Now, we can get into the conversations of what intelligence testing is actually used for, what is it actually testing, how do they operationally define it, is it potential for intelligence or is it just the book smarts, all of those things you debate before you get the frequency distribution. So once we get this bell curve, underneath it are the scores. And so the majority of people fall in those 100 to 150 to 85 to 115 range. So as we look at this, what we've done is we talk about standardizing or standardization. You guys have all taken standardized tests. So everybody gets the same test. Now, with Stanford Binet, everybody gets the same test. With the WAIS, the adult Wechsler Adult Intelligence Scale, everybody gets the same test. It is scaled for the Wechsler Intelligence Scale for children based on age ranges. But you standardize it, everybody gets the same test, and you end up getting this neat bell curve. If you remember, standard deviation is the degree to which, the mathematical degree to which scores vary around the mean. So if your mean is 100, and in a bell curve, your mean, median, and mode are the same score in a normal curve, then what they're looking for with standard deviation is where do we find that 68% and that 95% distribution. And so 68% of people who are going to take this test are going to fall between 85 and 115. So it's one standard deviation below and one standard deviation above. And then if you look at 95% of people are going to fall within two standard deviations of the mean, between 70 and 130, because a single standard deviation based on the criteria of how much all of the scores range around that mean is 15 points. 15 points. I always hate to say that you just need to memorize something, but in this case, memorizing those percentages is important. Standard deviation is looking for them. That is what we're trying to gain in that information, in that calculation. So what we use that kind of 95% for, which is what is the quote unquote normal, where do most people fall? And then we look at outliers and see, do we need additional services? And so maybe in schools, do we need additional services for somebody who scores above that? Do we need additional services for somebody who scores below that? Does that mean if they don't score well on a traditional IQ test that they aren't smart or intelligent? No, it simply means that the things that particular test we're measuring, they fell below perhaps the mean or below one or two standard deviations of the mean. When we look at the test itself, we have to look at whether or not it's a good test. So the two scores or two calculations that you're doing for determining if it's a good test are reliability and validity. Reliability being the consistency of the test, and validity being the measurement itself, is it actually measuring what it is supposed to measure? So you've operationally defined, and are those questions on that test actually getting at that operational definition? So let's start with the two reliability measures. The first being split half, and the second being test-retest reliability. So split half is exactly what it sounds like. Split half reliability is if you take the entire set of scores, and you've got the entire set of scores and you get a bell curve. And then you randomly choose 50% of the scores and you separate them. When you do a frequency distribution in a normal curve for either one of those halves, they should look very, very similar, if not exactly like the whole set. So this 50%, randomly 50% of the scores should distribute in the same bell curve. The other side should distribute in the bell curve, no matter how you randomly split those in half. Test-retest is a little bit confusing, and the definition in the book gets confusing as well. Because yes, it's what it sounds like, but it's not what your brain immediately thinks that it is. So test-retest. Now, you got to think about this. If you were to take a test in a class and I were to give you the exact same test again, you as an individual would do better. So that is not what test-retest is. That's not going to give us reliability. It's not going to give us consistency. Instead, what you're going to do is you're going to take this standardized test and you're going to give it to a set of people. And then you're going to take the same standardized test and under the same conditions with the same type of people or the similar group to whatever you've operationally defined as the group that you're testing, you give it to them, and then the distribution should look the same. So test-retest is the same test is given, but you're continuously getting the same bell curve distribution. Okay. Now, validity is it actually measuring what you expect it to measure? And you've got content and you've got predictive validity. Content validity is the content of the test itself. So it's the questions on the test. Are they good questions? Do they have a problem? Do they actually, if you're splitting it up, let's say, with some of Gardner's types of intelligence, if you're splitting it up with linguistic, logical, mathematical, and spatial measurements, are those questions actually getting at linguistic? Or are they written in a way where it's confusing, where it's actually logical? But are they actually written? And there are a couple of different calculations that can be done to do content validity. The questions themselves, are they good questions? Predictive validity is the result of the test predicting what you expect. Now, it's really easy to think about predictive validity with aptitude tests. Aptitude tests are things that are supposed to predict, for example, what you might be good at or what you might do in the future. Think of the SAT and the ACT. They're supposed to be aptitude tests that are going to predict success in college, so high school transition to college. Unfortunately, and if you've noticed that the SAT has changed its format a number of times in the last 10 years, it's because their predictive validity scores have been not very good. So the SAT is supposed to predict college performance. People aren't measuring, when they go back and look at people in college, aren't measuring the same as what their college performance was expected to be based on their scores. So they've changed the format a few times in order to get better predictive validity. Is it going to actually predict that achievement? It's really difficult to predict something that is a 4-year college education in one test and one measure, but they try. But that's what predictive is. Is it actually measuring ultimately what we expect to see it measure? Again, like I said, what do we do with these scores? In IQ in particular, oftentimes what the scores will do, and we have to be careful because sometimes these labels can kind of pigeonhole people, but oftentimes you'll see that if it's below a particular score or above a particular score, it means there are either disabilities or services for gifted, for example, in schools. Now, very rarely in schools for things like gifted and talented or for cognitive disability services are they ever going to just give one test or one measure. They might give the Wechsler along with some creativity tests, along with some timed attention tests or aptitude and achievement tests. But they might use those scores as kind of a baseline for what services need to be had.